All right, so here we're going to deposit 10,000 in a savings account now, and what's rate will compound continuously would have required for you to withdraw 12,500 at the end of 4 years. All right, so that means A is going to be 12,500. P is equal to 10,000. R is what we're looking for, and T is equal to 4 years. So now we just have to remember A equals PERT, and we plug everything in. So 12,500 equals 10,000 e to the 4t. And we can use our calculator, if we divide by 10,000, and then we have 12,500 divided by 10,000 equals e to the 4t. Take the ln of this side, take the ln of this side. This comes down. Ln of e is just 1. So if we divide by 4, divide that by 4, that should give us what t is equal to. All right, so let's type that into our calculator. Let's clear all that out. And so we had the ln of 12,500 divided by 10,000 divided by 4. So our rate is actually, did I say it was rate or time? This should be a rate because we had time already. 0.05579. So 5579. So yeah, so that's actually, I wrote the wrong thing up there. It's not a time, it's a rate. It was 5.5 79%. Okay. All right, let's do another one. So, if a dollar had been placed in a bank account in the year 1066 and forgotten until now, how much would be in the account at the end of 2026 if the money earned 2% interest compounded annually? What about 2% simple interest? Now, with this, after we see it, you'll see how compounding really works well. All right, let's do simple interest first, just because, that's kind of the simple one. And so simple interest is just going to be A equals P times 1 plus RT. Okay, well, we're going to put in $1, and we have 1 plus our rate was 0.02. And now we have to know how many years between here and here. So if we take 2026, and I'm just going to do this on my calculator, minus 1066, that's 960 years. So times 960. And since this is a small calculation, I'll just keep doing it on my calculator, times 0.02 plus 1. So that gives me a future value of $20.20. Not too good. What about the other one? Interest compounded annually. All right, so now we have, define my, here it is, A equals, now we have the principal again as just $1 times, now we have 1 plus the rate, which is 0.02, divided by 1 year, one time per year is compounded annually, it says, but raised to the power 1 times 960. So the key here is we're raising it to the power 960. And so when we do that, we're going to get 1 plus zero point zero 0.02 to the 960. Well, that's a big number. And so we get 180370243.40. All right. So how many is that? That's 1, 2, 3, 1, 2, $180,370,243.40. So now you can see compounding really does do a lot more for you than just the simple interest. So yeah, that would have been the case. That would have been a really good deal there. All right, so let's stop with that. We'll come back for some more.